So we've learned how to measure the concentration of a solution using grams per liter. Now, the challenges with grams per liter in chemistry, we don't often refer to how many atoms and molecules are reacting using the mass, using grams. We're usually referring to the number of moles. So a more common unit for concentration is what is called molarity. Molarity. Okay? What molarity represents, this represents the number of moles of solute per liter of solution. So what this means is, let's say you have a solution with a concentration of 3 capital M. What this means, the capital M is pronounced molar. So we would say the solution has a concentration of 3 molar. That means, according to our definition, there are that many moles of solute per, divided by, liter of solution. So this is the same thing as saying I have 3 moles per 1 liter of solution. And these moles can be whatever solute I am putting into the solution. It could be NaCl or CaCO3 or whatever it is. Okay? So the first big idea to walk away with here is that molarity represents how many moles of solute there are per liter of solution. Okay? So let's say you go to a lab and you're looking in the stockroom and you need to grab some hydrochloric acid. Okay, hydrochloric acid. And you need some 6 molar hydrochloric acid, which is what's listed right here. 6 molar. This is an extremely concentrated acid. So, what does that actually mean? Well, 6 molar, that means 6 capital M. What I want you to do every time you see that capital M, I want you to immediately rewrite that as how many moles there are per liter. So what this means, there are 6 moles of HCl per 1 liter of solution. That's what this means. So if we had this jar, we could zoom in and see the molecules, and let's say each dot here represented 1 mole of HCl, and let's say this was 1 liter, we would have 6 moles of this solute floating around. Okay? Now, because of our knowledge about grams and molar mass, we also know, and these problems will show up a little bit later, that we can convert between moles and grams using the molar mass. So that's something to be on the lookout for as we do these problems, remembering that grams and moles can be converted. Now let's look at how we would apply this to some particular solutions and problems. Let's say you had a problem that said, what is the molarity of a sulfuric acid solution that has 4 moles of acid dissolved in a 0.25 liter solution? Now, here's where things get a little tricky. When we talk about solutions, we're going to start having multiple numbers given in the problem. So we're used to just seeing one given and using that to do our problem. We now have to recognize that we're going to have multiple given, and we really need to slow down and think through what the problem is asking for. So the problem is saying, what is the molarity? Okay, so molarity, I just learned molarity represents the number of moles per liter of solution. So this really means what I'm trying to figure out is how many moles there are per the number of liters that I have. So let's see what's given in the problem then. I'm going to label this. I'm given moles, okay, so I have moles, and I want you to do this every time you get this, and I have 0.25 liters, okay? Well, this is actually pretty easy. If I want to get the molarity, I just take the number of moles I have, 4 moles, divided by 0.25 liters. So the concentration, remember molarity is a unit for concentration. Concentration here would be whatever 4 divided by 0.25 is, okay? Which would give us a concentration of 16 molar. Wow, extremely concentrated solution. Okay, so again, we broke this down. What's the problem asking for? What are my givens? How can I use those to solve the problem? Another type of problem we could do would be like this. How many moles of HCl are needed to make 2 liters of a 3 molar solution? So again, Multiple givens. You got to break it down and think what we're asking for. Don't just memorize a process. I'm trying to figure out how many moles. Okay? And I'm given 2 liters, and I'm given 3M. Oh, okay, so 3 capital M. That does not mean 3 moles. That's not what that means. What this means, remember, capital M is the number of moles per liter. So I can rewrite this as 3 moles per 1 liter. And this is what I want you to do. Every time you see units of molarity with a capital M, rewrite it as that many moles, like we did here, divided by 1 liter, because that's the definition. So now let's think about what I need to do. I'm trying to figure out how many moles I need to make 2 liters of a 3 molar per 1 liter solution. So we could set this up in 2 ways. We could say, okay, in order to make 2 liters of a 3 moles per 1 liter solution, I can set the problem up like this, cancel out my liters, and I'm left with 2 times 3 over 1, which would mean that I need 6 moles of HCl solute. Or I could think of it as a ratio, as a proportion. If I'm going to have 3 moles per every 1 liter, how many moles do I need for, how many moles do I need for 2 liters? So here I would just cross multiply. So I'd have 3 times 2 equals x times 1. So x is equal to 6, number of moles, just like I got here. Either way, totally appropriate way to solve the problem. Okay? Let's take it to the next level now. Because we don't often measure in the lab things in moles, we're usually using electronic balances that measure things in mass, in grams. So let's say we want to make a solution of Kool-Aid. Okay? Kool-Aid is made of glucose, which is a sugar, which has the molecular formula C6H12O6. You want to make 0.3 liters of a 0.1 molar solution of Kool-Aid. What mass of Kool-Aid would you need? Okay, so I'm trying to figure out mass. That's grams. I need to figure out how many grams I'm given. I need. Okay, I have liters, and I have 0.1 molar. Okay, so I need to rewrite this. That's 0.1 moles per 1 liter. So I'm trying to get to mass. Now in the past, I figured out the number of moles first. If I stop and think and I get the number of moles, I can then convert that to grams using the molar mass. So similarly as to before, if I want to make 0.3 liters and I want 0.1 mole in every 1 liter, if I set that up here, okay, I do 0.3 times 0.1, I'm going to realize that I need 0.03 moles of Kool-Aid. Great, done. Nope, not yet, because the problem is asking for mass in grams. Well, now I got to take my knowledge of stoichiometry, my conversions. If I have 0.03 moles of Kool-Aid, which has this formula, C6H12O6, I need to convert that into grams using the molar mass of this compound on the periodic table. So I check the periodic table, and when I do that, I see that it has a molar mass of about 180 grams per mole. So I need to plug that in appropriately. Since I have moles in the numerator here, I need 1 mole in the in the denominator here, and on top, 180 grams. There's my setup. So now if I cancel out moles of C6H12O6, I'm going to be left with 0.03 times 180 over 1. 0.03 times 180 is going to give me about 5.4 grams of Kool-Aid I would need to add to 0.3 liters of water to make this solution have this concentration. Your turn. Here's a new problem. Give this one a shot by yourself. So this problem is very similar as to before. Okay, just a little grammar thing there. What mass would you need if you have 0.3 liters and 0.08 molar? Well, this means 0.08 moles per 1 liter. So 0.3 liters times 0.08 moles per 1 liter. Okay, well, 0.08 times 0.3, that's 0.024 moles. But the problem is asking for mass. And again, it's Kool-Aid again. It's the same molecular formula, C6H12O6, as before. One thing I probably could have given you in the problem, but you can recognize too. So I take 0.024 moles, and I know that 1 mole of Kool-Aid had 180 grams. So if I multiply 0.024 times 180, this would be 4.32 grams of Kool-Aid, which is less than what I made before. So that's one way I can check. If I put less Kool-Aid in, it probably will not taste as strong. So this number seems to make sense. So again, whenever you're doing a molarity problem, slow yourself down. You're going to have multiple givens, so just really think about what the problem is asking for and how you can use all the tools in your tool belt to try to solve it.